Hello, I'm Richard. I'm a tech lead at Prem, and I'm working on a project called Ayup, um, where I've just got secure connections to work. So encrypted connections using libp2p. So I'm just going to demonstrate this. I'm going to start the Ayup server, which basically this is like our build and deployment server. So we send it source code and it figures out how to build it and deploy it, or at least it will do. Um, and then, okay, so I mean that's running on localhost, but you can imagine maybe it's running on a server somewhere else. And then we've got our client, which is running locally. Okay, so what we can do is we can try to push some code to this server. Okay, and it says not authorized because basically the public key for the client is not registered with the server. So in libp2p, every node in the network has a private key and a public key. So it's standard public key cryptography. And you can and each peer has a peer ID which is derived from the public key. And you can basically say to each node, here are the nodes we trust, and then those nodes will be automatically able to create a secure connection and log in with each other. So what we can do is we can do login and then say login to the server. Okay. And then you can see on the server it's come up saying, do you want to authorize this client? And it has the peer ID listed just there. So we can say, yes, we want to authorize this client. Okay, so now the client is authorized, and if we try to push again, yeah, now we can do it. Okay. So you can see on the server side, you can see that we have AY login. It says to connect with AY login, and it gives this big long address up here. Okay, so this is the libp2p multi-address, which specifies like what protocol you want to connect with and the IP address or the DNS address, whatever, and the port and everything. And then it also specifies the peer ID. So you know that whatever's running at this address, it has the private key to go along with this public key. So from the client side, we know that the server is the one that we want to connect to, assuming the private key hasn't been stolen. And then below this, we have this log message saying authorized client, and it has another peer ID, which is in fact the peer ID of our client. Yeah, it's listed just here when we did the login. So you can see both those peer IDs are the same. Yeah, and so what you just saw is when the client tries to connect to the server, we get a message on the server console saying we haven't seen this client before. Do you want to connect? And then once it's saved, then from now on we can just keep connecting to that, and Ayup will remember what clients it's seen. So This is the way this is working. I mean, libp2p does loads of stuff, but the way this is currently working, it's a lot like if you share some SSH keys, or if you use like Bluetooth pairing, that kind of thing. And we can also pre-configure the server to have particular client IDs authorized. So we can set a we can set an environment variable which lists a bunch of client IDs. So yeah, you can see there that it has these client IDs pre-authorized once I pass the right environment variable to it. So you can sort of pre-configure the server to accept particular clients, which will come in handy when we're running Ayup in like a cloud environment where we want to pre-configure everything. Okay, and we can take a look at the source code. So I decided to use libp2p for this, just because it has a nice library. So if we look here, basically we have this in function ensure private key, which if we don't already have a private key in the right environment variable, then we'll generate one, which we generate a ED25519 key, which is pretty up to date and nice, I think. And basically, we'll then save it to like a .env file in the user's config dir. So this is just like a way of, let's say you just run the server or the client without any pre-configured environment variables. We'll just create the encryption key and save it to a file where we reload environment variables from it. It's just the standard Go .env implementation, which we use your home directory to store that. So when we get to listening, so when we're listening from the server side, and this is something where libp2p makes things a bit more complicated than usual, because libp2p, it's, well, as the clues in the name, usually you'd have a bunch of peers who are all equivalent or close to equivalent, but Ayup actually has a classic client-server architecture. So for now, I mean, this is a little bit like fishing with dynamite using libp2p, but when we listen, what we do is we create a libp2p host, and then from this point, like, libp2p is already listening and will accept connections and stuff. But so that's differing a bit, because when you get down here to where we actually call listen from GoStream, I mean, really this is just a wrapper to make libp2p compatible with the standard Go networking stuff. So yeah, all this is doing is just making a wrapper that sets a callback, so that we get the stuff like accept and close, and we can get an address and stuff like that. Because Ayup uses gRPC, which is not doesn't come with any libp2p support built in, and gRPC kind of makes a few assumptions about how you're going to make a connection and stuff. On the client side, it's a bit simpler. We just set a callback somewhere to create a new dial out. Oh yes, down here. Yeah, sorry. This is the fallback for when we haven't set a multi-address. If we get a regular address, then we just make a regular connection to that address. Down here we have where we make our gRPC connection with libp2p. We have to set a with context dialer callback just here, which actually just ensures there's a connection, right? Host connect doesn't always actually make a connection. You might already be connected. It might have already happened. The other peer may have already connected to you. Although I've deliberately set this so that our client host doesn't listen for connections. Okay, so one odd thing, if you're using the P2P with gRPC, you have to add no pass-through to the front of the target address, or just set a dummy target address, because gRPC tries to do some sort of like lookup on the address. You know, even if you set like a custom dialer, like it still tries to do some work on the address before tries to do some sort of DNS lookup or something. And it gets really confused by the gRPC multi-address. I mean, you can actually see in here that we don't even use the target address that's passed to us, so I mean I don't really even need to pass the target there. Just one thing to be aware of if you try to use libp2p with gRPC. Yeah, we also have like some slightly other things, like we set transport credentials to insecure because we're not using like gRPC's idea of a secure transport. We're using noise, I think, was it called noise, which comes with libp2p. Yeah, set the security on the libp2p connection. Okay. I think that's it really. So yeah, this works nicely. Don't have to set up certificates or anything like that if we're using SSL, especially not self-signed certificates. And don't have to generate keys with OpenSSL or GPG or any of that other stuff. Very nice. And that's it. Goodbye.